hopefully all this is review, and if it's not, I'm sorry. Please come in if you feel like you need help with some of this. Sohcahtoa. That S stands for sine, the O stands for opposite, the H stands for hypotenuse. We're talking about trig ratios of a right triangle. If I have an angle here, then this would be called opposite, this would be called adjacent, and then that would be called the hypotenuse. It all depends with what angle you're referencing. Correct? Awesome. So Sohcahtoa, I think you guys are pretty good at that. And then these are the reciprocals. Cosecant is how you say that one out loud. Here it is, cosecant. And then SEC, you call that secant. And then COT, the cot, you call it cotangent. And they're reciprocals. What does that mean? If I tell you that sine is 3/5, that means the reciprocal of sine is cosecant. Cosecant will be 5/3. And that's all it is. It just means flip your ratio. Cool or not cool? Very basic. Let's chat about the 6 trig properties with respect to the unit circle. All right, so let's emphasize quadrant 1. So here's quadrant 1. And I know that, and I'm just going to plot these coordinates, just these two. I know that the unit circle has a radius of 1. Are we okay so far? And I want to focus on that specific triangle right here. That coordinate is some x, some y. And I'm just looking at some angle. I don't know what angle, just an angle. It could be a special angle, it could not, it may not. Are we okay so far, guys? Okay. So notice that this distance here in green, that is just some x. And this distance here in blue, that is just some y. And there it is for color coding. I tried to color code. If you use your trig ratios, this Sohcahtoa over here, Sohcahtoa. So I'm going to write that right here. Sohcahtoa. I can tell you that sine of that angle is equal to opposite. What is opposite? Y over hypotenuse, 1. So y divided by 1 is just y. Are we okay with that, guys? All right. Cosine. Cosine of that angle is adjacent. What's adjacent? X divided by 1, because the hypotenuse is 1, the radius is 1, guys. And x divided by 1 is just x. How do we feel so far? Perfect. So now you know that sine is y, sine theta is y, and cosine is x. Tangent. Tangent is opposite over adjacent. So opposite, y, divided by adjacent, x. Now let's do the reciprocals of those. The reciprocal of sine is cosecant, CSC. Cosecant, and then I just said reciprocal, right? So 1 over y. The reciprocal of cosine is secant, so I'm going to write SEC. So the reciprocal of x is 1 over x. And I'm going to write cotangent. The reciprocal of cotangent is x over y. Have I lost anyone? Okay, are we still okay? All right, perfect. So let's go to the next page. There is a huge blank on purpose. Let's see how much of this you can do from memory. So I'm going to insert my unit circle. Relax, guys. Try to make it pretty. Oh, it's actually one of the nicer circles I've ever drawn. I do have a little circle thingy here that I could put. Look, here it is. I could use that guy, but I don't like using it. I don't know why. All right, let's continue. Okay, so here are my special angles. 30, 45, 60. I'm going to call this 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and then finally 360. Those are all degrees. Do you guys remember your radians? I'm going to label the radians in green. 0, pi over 6, pi over 4, pi over 3, pi over 2. In quadrant 2, 2 pi over 3, 3 pi over 4, 5 pi over 6. See, most of you already know it, right? At 180, it's pi. Add 1/6 pi to pi, so that's going to be 7 pi, so 7 pi over 6. Same logic for the next one. 5 pi over 4, 4 pi over 3. Let me make that pi better. I don't see any mistakes. 3 pi over 2. What's the next one? I don't know, Travis. Denominator 3, double the 3, subtract 1. 5 pi over 3. Denominator 4, double the 4, subtract 1. 7 pi over 4. What's the last one? You're 1/6 pi away from 2 pi. Guys, make sure we know this. You guys are scaring me. 11 pi over 6. I can tell. Make sure you know this. I'm not telling you to do like an hour's worth of homework every day, but at least look at the unit circle. So I can tell the only time you're looking at math is during this class. So guys, start investing just 10-15 minutes a day. 10-15 minutes a day looking at that unit circle. The logic is simple. You don't have to memorize anything. If you need to memorize anything at all, it would just be the first quadrant. After you memorize the first quadrant, everything else can be gotten just with basic logic and just a little bit of brain power. The coordinates, well, these ones here in the corner in blue, those are the easiest ones, right? So that's going to be 1, 0, 0, 1, negative 1, 0, 0, negative 1. And then at 30, it's square root of 3 over 2, comma half. At 45, it is square root of 2 over 2, comma square root of 2 over 2. At 60, it is 1/2, comma square root of 3 over 2. And we derived those from scratch last time, if you remember. And then from there, just reflect. In quadrant 2, the x's are negative. So at 120, you're going to have a negative half, comma, square root of 3 over 2. That's a 3 there. At 135, you're going to have a negative square root of 2 over 2, square root of 2 over 2. At 150, negative square root of 3 over 2, comma half. 180 is already done. At 210, they're both going to be negative because that's quadrant 3. So both x and y are negative. Square root of 3 over 2, comma, negative half. At 225, they're both negative. Square root of 2 over 2, comma, negative square root of 2 over 2. At 240, the x now is a half, so negative half. Square root of 3 over 2, but negative. And then 270, 0, negative 1. At 300, the x value is positive, 1/2. The y value is negative, so negative square root of 3 over 2. That's a 3 there. Just came out dumb. 315, they're both square root of 2 over 2. It's just the x that is, it's just the y that is negative. And at 330, same deal. Square root of 3 over 2 for the x and negative half for the y. And there it is. You don't have to be that fast. You don't make your brain work really hard. You don't have to make your brain work really hard. If you know just enough, like, to register in your brain, oh, this is what I need to know. So don't make your brain work really hard, guys. Yes, you can just memorize that, but I wouldn't. Just memorize the first quadrant if you must. You think NASA engineers know the unit circle? They 100% know the unit circle. I guarantee you. They're using it all the time. Maybe not like this directly, but they're using it all the time. Can I go to the next example, guys? Or you want me to zoom in somewhere? All right, here we go. That, by the way, we just did that for fun. I hope you had fun with that one, right? All right. We're going to reference it. So example 1, find the exact values of the 6 trig functions at 60 degrees. All right, so do I have a highlighter? I do not. I mean, I'm sure I can find one. Well, let's see. Does this highlight? Here is 60 degrees. It doesn't really highlight. I can kind of see yellow there. I guess that's fine. So that's what we're looking at. So I'm going to write cosine, and I'm going to type 60 degrees. Now, yeah, you can use a calculator, but, well, for these type of questions, don't. So what do we say up here? If you look right here, what does it say that cosine of some angle is? It's just your x coordinate. So cosine of 60 degrees is just 1/2. I feel like some of you guys are scared. It's not scary, guys. Look, check it out. We'll do another one. Sine 60 degrees. So according to the notes that I wrote up here, did we understand this before I even get started? Because if you didn't understand this, you're going to be clueless. All right. According to this says that sine of any angle is just your y coordinate, right? So I come over here and I say, okay, at 60 degrees, here it is in yellow. I'm looking at my y coordinate, that's square root of 3 over 2. So I type sine 60 and I put square root of 3 over 2. See what I did there, guys? And they want me to keep going because they want all 6 of them. So now I'm going to write tan of 60 degrees. And tan says y divided by x. So that's what I'm going to do. That's what it says right here. Tan says y divided by x. So I write my y value, square root of 3 over 2, and I divide it by 1/2. The best answer is square root of 3. If you write square root of 3 over 2 over 1/2, I'll count it right. Cool or not cool? Cool. What's the reciprocal of cosine? Secant. Perfect. Secant of 60 degrees? 2. You can write 2 over 1, and that's fine. What's the reciprocal of sine? Yeah. 2 over square root of 3. Now, when you take your UH quiz, they're going to do something called rationalize, which means do not have a radical in the denominator. So there it is. So now this turns to 2 square root of 3 over 3. They're both correct, by the way. Are we okay so far? Cotangent of 60 degrees. Well, it's x over y. So 1/2 divided by square root of 3 over 2, which is the same as 1 over square root of 3, which if I rationalize this, it turns to square root of 3 over 3. So all 3 in red are correct, but they probably want the square root of 3 over 3 one. How are we feeling, guys? Okay, now I want you to see, don't write anything down, just listen. So I'm going to take out a calculator, and you guys tell me what you think the calculator is going to tell me. Come on, buddy. All right, I can see that I'm in radian mode, so let me change it to mode, degree. Okay, so check it out, guys. Just look up here. You don't need to write anything. So if I write or type cosine 60, I'm in degree mode. What do you think it's going to spit out? 0.5, yeah. Look, 0.5, that's what we got. If I type sine 60, this is not a CAS, so it's not going to give me the pretty square root. But if I type sine 60, it's going to give me square root of 3 over 2. So check it out. That 0.866, that is square root of 3 over 2. Square root 3 over 2. Look at that, guys. Isn't that cool? Didn't you ever wonder, like, where do these values come from? Well, now you know. Look, we derived it from scratch. Okay, well, I think that's cool, but you guys are like, just, what's the next question? All right, so here we go. Evaluate the sixth trig for angle at 180. So we're doing the same thing, but at 180. So we're going to be looking at that unit circle over and over again. So what should we do first? Cosine? Cosine of 180 degrees. I go to my unit circle. Cosine is the x. At 180 degrees, what is that x coordinate? -1. I heard someone say it. Sine 180 degrees. What is the y coordinate? 0. Then tan 180 degrees. Tangent is y divided by x. 0 divided by -1. That will give you a value. That's going to give you a value of 0. Now let's do the reciprocals. Cosine, the reciprocal cosine is secant. So secant of 180 degrees is -1, because the reciprocal of -1 is itself. That's the only number that it happens, -1 and 1. The reciprocals of -1 and 1 are itself. Cosecant is the reciprocal of sine. And does 0 have a reciprocal? No, so this one is undefined. You can also say does not exist. And then finally, cotangent of 180, the same deal. Can I take the reciprocal of 0? No. Undefined. You can also say does not exist. They're both the same. How are we feeling, guys? You feeling all right?
I wish I could do it right now, so that I remember everything.
Oh, you're going to remember everything.
Yeah.
You're smart, miss. It says the terminal side of an angle theta contains a point -5, 2. Find the exact values of the 6 trigonometric functions of theta. Use radicals, no decimal. All right, so here's how you do it. First, identify what quadrant is that in. -5, 2. -5, 2. Quadrant 2. So I'm going to exaggerate quadrant 2. So here I am, exaggerating quadrant 2. -5, 2 point. So the angles that go from the origin and connect those 2 points and make a right triangle like so. Sometimes they call that a reference triangle. The angle that we're actually looking at, the angle is actually this one. But we're going to use our reference one to help us out. You guys ready? This is -5. This is 2. Before I do anything, I need to figure out that hypotenuse. I'm going to go square root. And I guess to be technically correct, put the -5 in there. And then the 2 squared. If you leave the negative out, I wouldn't penalize you. I would say I think you know what you're doing. 25 plus 4 is 29. Leave it as square root of 29. The hypotenuse, or the radius, will never be negative. Are we okay so far? All right. Here we go. I'm going to write cosine of this angle. I don't know what that angle is. We're going to use our reference to help us out. Chavez, what are you doing? I'm doing Sohcahtoa. Sohcahtoa. Cosine is adjacent over hypotenuse. Look at that green angle. What's adjacent? -5. What's hypotenuse? There it is. Chavez, why are we using the green one and not the red one? Well, if I told you to look at the red one, how are you going to see what's adjacent? Oh, what's adjacent? So we're using the green one to help us out. Cool? All right. Sine. Sine of that angle. Look at the green one to help you out. Sine is opposite over hypotenuse. So what's opposite? 2 over square root of 29. Let's go to the next one, tan. Did they want all 6 of them? Yeah. Tan is opposite over adjacent. So it's just going to be 2 over -5. If you want to put the negative in the front, that's fine. And now we're just going to do the reciprocals. The reciprocal cosine is secant. So I'm going to write secant of that angle. Square root of 29 over 5, -5. If you want to put the negative in the front, that's fine. Cosecant of this angle, square root of 29 over 2. And cotangent of this angle, negative 5 over 2. I think we got them all. 1, 2, 3, 4, 5, 6. Yep. How do we feel? Yeah. And see, it wasn't so bad. So that's what your activity is going to be today. Just some of those. Example 4. If an angle theta terminates in quadrant 4 and cosine is 3/5, find the exact values of the other 5 trig functions. Same thing. But now they're telling us, I'm in what quadrant? 4. So they're not giving us a coordinate. Now they're giving us a ratio and a quadrant. So exaggerate quadrant 4. There's quadrant 4. And make a triangle in the quadrant 4 like this. Here's the actual angle that they want. But we're going to use our reference to help us out. Using that reference to help us out, I know that cosine is adjacent over hypotenuse, so this must be 3. This is my hypotenuse, that must be 5. I can do Pythagorean theorem to figure out the distance in the y. Square root of 5 squared minus 3 squared, because the hypotenuse is always the longest side, so now I'm subtracting. Square root of 25 minus 9 equals square root of 16, so I get 4. Now I'm going to put the number 4 in there, but I'm going to put a negative in the front. Why did I put a negative in the front? Perfect. Put that in your notes. We put a negative there because the y values are negative in quadrant 4. They already gave us cosine, but I'm going to type it in here just in case one more time. Cosine is 3/5. That was given. Sine. Sine of that angle is... Not everyone at the same time. Negative 4 over 5. I'm just doing Sohcahtoa, guys. Not Sohcahtoa. That's just nasty. Sohcahtoa. So now we're going to do tan. Tan is opposite over adjacent. Perfect. Negative 4 over 3. And then the reciprocals are easy, guys. The reciprocal of cosine is secant. It starts with the letter S. And then just flip it, 5 over 3. The reciprocal sine is cosecant, so C is C. Put the 5 in the top, the 4 in the bottom. If you want to put the negative in the front, that's fine. There it is, my negative there. And the reciprocal of tan is cotangent. So negative 3/4. And there it is. How are we feeling, guys? Hey guys, get happy because we have pizza coming in a little bit. We don't have pizza, guys. I'm sorry. What would make you guys happy? What type of food? Would tacos make you guys happy? Or would pizza make you guys happy? How about cookies? I love cookies. Cookies. Have you ever had Chick-fil-A cookies? Oh my God, you haven't lived. No, Chick-fil-A cookies are like super heavenly. All right, last one. Y'all ready? I bet you Harry Styles knows how to do all these questions. No, I think he does. He's British, right? So I bet you he did all this in his... if an angle theta terminates in quadrant 1 and cosecant is 13 over 12. All right, make life simpler for you guys. As soon as you see cosecant is 13 over 12, give me the reciprocal of cosecant. You can actually go back and forth with it. Yeah, so sine. So that means sine is 12 over 13. The reciprocal of cosecant is sine. The reciprocal of sine is cosecant. You can go back and forth with them, guys. Cool? So sine is 12 over 13, and it says find the exact values of the other 5 trig functions. I'm in quadrant 1, so here I go. I'm going to emphasize quadrant 1. There's quadrant 1. And because I'm in quadrant 1, I don't need my reference angle. Well, I guess technically that is your reference. And that angle, let's see, opposite hypotenuse. So that's 12, that's 13. So if I want to figure out what this guy is, square root of, or I don't know, maybe some of you guys already know it because it's a special type of triangle here, right? Let's see, what's 13 squared? 169? And then 144? 44, 54, 64. Square root of 25, so that is 5. We okay so far? All right, and then from there, we're just gonna find the others. So they already give me cosecant, so I'm gonna write CSC theta equals 13 over 12. And since I already did the sine one, I'm gonna put that on the side. Sine theta is, oh, what happened? 12 over 13. Okay, let's see, cosine. Cosine is adjacent over hypotenuse, Sohcahtoa. Sohcahtoa. So 5 over 13. And then tangent. Tangent is opposite over adjacent, so 12 over 5. Perfect. Let's see, which one do we not have? Secant. Secant is the reciprocal of cosine, so 13 over 5. And then cotangent is the reciprocal of tangent, 5 over 12. How do you guys feel? Not bad, right? We have a little activity. You can do it in groups